Hey everybody, it's either Tuesday, October 4th or Wednesday, October 5th, depending on which house you're in and what day you're attending the Courage Retreat. We are on page 28 today. That's the left side. We're saving page 29 for investigation 2.3. So page 28, investigation 2.2, investigating forces. And once again, we're researching how objects speed up, slow down, and change directions. Before we get started on the investigation today, we want to look back at investigation 2.1, a little review on how you can describe motion of an object and explain how your reference frame affects that description. So we have some things to write down in our notebook, some things you want to make sure you have. For example, average speed equals distance traveled divided by time. Acceleration is the rate at which an object changes speed or direction. Velocity is both the rate of change of an object's motion and its direction, and reference frame is the point from which you observe motion. Observations of that object depend on the location of the observer. So a few different vocab words to write down on pages 24 or 25, wherever you have space. And then we want to review how we measured that speed and average speed of an object. So this is an example of how you may measure that. You had 3 different trials. It's always good to do more than one. And you're keeping track of the distance, which was in meters in this case, and time for that ball to move, which would be S for seconds. And then you can calculate your average speed on the right here, 3.2 divided by 5.59. That's meters per second, and that goes in the average speed column. So we just want to review how to calculate average speed. We're going to be looking at investigating forces, how they affect the motion of an object, and analyzing, interpreting data from motion. So that's what this lesson is going to be about on 2.2. So before we start 2.2, we want to think back to 2.1, which was on Monday and actually last Friday, so part A and part B. And we want to think about how'd you measure speed in the last lab. So you probably had a couple marks on your floor, and you started at point 0 and you measured speed to like 2 meters or maybe 1 meter, depending how you decide to do this. And you use that time to kind of keep track of speed. So keep that in mind for this lab, because we're also going to be measuring speed and how it changed. So as you start investigation 2.2, there's a lot of questions to answer. We can't just dig into all the fun stuff. And you're going to be using the PDF if you're at home to get all this set up. Drawing a diagram, you're going to want to read the forces in motion reading, and that is on page 19. You're going to collect evidence, describe forces, and then create a way to exert a continuous push on the ball, and then we're going to be moving on. So here's your list of materials. Remember, no one's going to be walking near the rolling path. There's a ball. Do not throw or bounce the ball. These will break things for sure. They're stainless steel balls, so be careful with what you're doing. And then your to-do list today is you're going to create a plan and data tables for the question, how does the surface on which the ball rolls affects its motion? So you should have a carpet square, and you also have the tile floor to compare those two. And we want to make sure we get through steps 1 through 4 in your notebook on page 28. If you get more time, you can move on to steps 5, 6, 7, and 8. But there's a good chance with it being a shortened day for advisory, we won't get to that if this is a Wednesday class. So steps 1 through 4 for sure on page 28. And if you get time, move on. Hope you have a great day, Cardinals. See you later.